Okay, I'm here with Andrew Ash from CSIRO's Climate Adaptation Flagship. And Andrew, I guess the first question is, help us to understand how the science of climate change projections is kind of derived. How do scientists develop these models and assess them over time and test them and update them?
Okay, so climate projections that we use are derived from a range of global climate models. Mm-hmm. And those global climate models are evolving over time to reflect our improved understanding of the science of ocean processes and atmospheric processes. So we capture that new understanding into the various global climate models, and through the Intergovernmental Panel on Climate Change process, more than 20 of those models are assessed, and then they're used in the projections process. So we take the output from those various models, which are often at fairly coarse scales of resolution, mm-hmm. and start to look at them and analyse them to derive projections at scales of regions down to very local levels.
To local levels. And CSIRO, from an Australian perspective, how do you feed into those 20 models? How many of them are you involved in?
CSIRO, in partnership with the Bureau of Meteorology, we produce an Australian model, which is part of the IPCC process.
Yep.
So in the last IPCC assessment report, there were 23 models that we used. CSIRO contributed one of those, and we're looking to contribute one into the next IPCC process, the fifth assessment report.
Sounds like a lot of numbers.
Yeah.
So help us to understand uncertainty within those models. What's the degree of uncertainty within that huge grouping of models, and then how they evolve over time?
Yeah, well, first of all, worth making the point that uncertainty is an important part of science, science, but it's particularly important in the climate area, particularly as we look forward into the future, because there are in fact two sources of uncertainty. One is our understanding of the physical system and incorporating that into the climate models, and as a consequence of that uncertainty, we have a variety of outcomes that come from the models, even when you use the same future emissions scenario.
Okay.
The second source of uncertainty is one related to us, human beings, how many emissions we're going to put into the atmosphere.
How many times cows fart, all that kind of stuff?
Yeah, something like that, yeah.
Okay.
Although burping is the main thing with cows. We're uncertain about those future emissions.
Of course.
And so that, depending on how we respond as a society to reducing our emissions, so that creates, in fact, a fairly wide range of uncertainty, particularly when you're looking to longer time projections.
And that's as much uncertainty about how we behave as it is about the technologies that we develop that, can dramatically change our energy mix.
Yeah, so that's a whole range of social, technology, economic drivers of our emissions for the future.
And they're all built into these models that the world is grappling with as a group. How many scientists are involved in the IPCC?
Oh, well, overall, when you look at all who are involved in it, there's thousands involved in the overall process, from Working Group 1, which deals with the fundamental science, through to Working Group 2 that looks at impacts, vulnerability and adaptation, and Working Group 3 that focuses on mitigation.
Okay, holy schmoly, it sounds big. And when they talk about peer review, it's basically those scientists, a peer group of scientists who are reviewing each other's work as it evolves.
Well, nearly all of the science that goes into the IPCC process has already been peer reviewed. Not all of it, but most of it, particularly in Working Group 1 in the fundamental understanding of the science. The vast majority of that has been peer reviewed, and then the process is synthesising and integrating that body of knowledge that's accumulated over a number of years into the IPCC reports, and that IPCC chapters themselves then undergo a serious amount of review. So it's a process which starts with the fundamental science and then goes through a number of review processes.
Fantastic. Thank you very much.